Okay, now let me start my video presentation. In this project, I will develop a data-driven tool for international students applying to the overseas universities. And the name for this tool is Study Match, which is also the title of this project. In this step, the tool is mainly for Chinese students because the data set is based on the historical record of Chinese students. And in the future, if I can collect historical data of students from other countries, it will be also suitable for other international students. In this time last year, I was an international student who struggled to apply to U.S. universities because there are too many choices, and I don't know which one is the best fit for me. So after that, I experienced a lot. I asked many educational institutions for help, and after experiencing that, I understand that maybe I can solve this problem with the power of data. So I started this project. The problem is international students know little about choosing overseas schools, and my target is to provide them with assistance and guidance in applying overseas schools. So my method is to use descriptive statistics, inferential statistics, and statistical models to make predictions of their applications. Uh, and the data set here, I will have the historical data of university applications, which is just scrapped from the web pages. Okay, and I have 5 steps to complete this project. Data collection, data cleaning, data exploration, data modeling, and outcomes. Now let me explain them in detail. In the first step, data collection, I have two parts: data download web pages and scrap data from local web pages. The reason why I did not scrap data directly from online web pages is because I want to prevent data transfer issues resulting from network disruptions. I mean, um, if my network is not stable, then the scrapping process may be interrupted. So I want to avoid this. And let's demonstrate it. Let's demonstrate this start with a simple example. Okay, and I will do data collection with Python, and here's some necessary packages. And here I use this tool. I use Py Auto GUI and Beautiful Soup to conduct data collection. First, I will download web pages with this Pi Auto GUI. It will simulate the operation of mouse and keyboard to download pages from the browser automatically. Now let's define this two function, and let's download page from the web page. Now I will download a page of the historical application data of Lehigh University. This Chinese character is Lehigh, means Lehigh University. And now it will operate the accessing the browser and save the pages to my local page automatically. I won't operate my mouse or keyboard anymore. It will finish this process automatically. Okay, now it has downloaded is this file. Okay, and in this page there are some data about the application. So now I will use this uh, I will use this beautiful soup to locate the data. We can see that the data is in this let's say is in this the label of T body. Yes, the data is within this T body. So I will use the beautiful soup to package to locate this T body and extract data within it. Let's say it is in the T body. So now I will use this beautiful soup to firstly to open this local web page, and then it will find the T body and it will extract the data. Let's say one. So let's say then it will store the data into this info variables, and now it has 10 elements, and the info will be like this. So it is I think it is unstructured data. So the next step is to do data cleaning. I will reformat data sets. I will create and discard features, and I will use comprehensive database to store the data. The first step is to convert a URL encoded string to Chinese characters. And the second is to do some data wrangling, like drop unnecessary features, unpack overloaded features, and normalize the numerical values. And then I will store this data set into the database. So for the first one, you can see that this is say URL encoded string, and I will convert it to Chinese character. I will also demonstrate it with the Python with this super notebook. I will use the data frame to load the data from the info from this list, and it will be like this. uh, ID and the student's name, the student's degree, the student's GPA, and the student tests, and undergrad school major, application schools, and application majors. And I will define some functions to to process and clean the data. So after cleaning, it will be like this. Although you may not, you cannot read the Chinese characters, but now it is the structured data, and this Chinese characters has their meanings. And then I will also drop some unnecessary features and unnest overloaded features. I created some new features to receive information from the overloaded feature. For example, this test, this column contains scores of many tests like TOEFL, GRE, and GMAT. And after cleaning, it will be like this. It will have four new features to demonstrate its score respectively. And then I will also reformat the data set so that it will be like this. It has only one undergraduate school and only one application schools. But if students apply to more than one schools, in this data frame, it will have three columns to demonstrate which schools the student applied to. But in this but after reformatting, it will have three rows with one column to demonstrate the schools the students apply to. For example, for this file for 088, it will like this. Let's see. Okay, in the data frame before reformatting, it will have three columns, and now it will have three rows. This is more structured for analysis. And then I will insert this data set into my database. So after I here I use PostgreSQL, and after importing the database, I can use SQL to select them. The reason why I use database because I will conduct this step for many times. I won't just improve the historical of Lehigh University. I will also improve the data of other universities. So I will input the full data into database, and then I will also have some other tables, because now you can see it displayed in Chinese, and I will also have a table like translation to translate this Chinese characters to English. And now we can see in this database table, the data has already been imported to this table, and now it is structured data. I will analyze this data using this database. So this is for data cleaning. And the next step is data exploration. I will use uh, descriptive statistics and inferential statistics to analyze the data, and discover the patterns of the numerical features. And I will also quantify the universities of majors. The main idea is to evaluate the undergraduate schools and a school's honor application based on the rankings. And I also categorize majors and determine whether the majors of students, the undergraduate major of students, and the prospective master's majors are aligned, whether they are consistent. So now so far I complete this part, explore the pattern of numerical features, and let me take an example to show to show what I did. And now let me connect the database and pick out the information of applicants to apply to Lehigh University. Now I will use many functions and plots I just learned in our course and the data camp tutorial. Firstly, I want to analyze the statistical information for GPA. It has the statistical information, and it has a histogram for GPA. We can see that it's almost a bell curve, except a gap in this maybe 3.5 or 3.6. Maybe in this interval there is a gap. And I can also analyze its TOEFL test, its yields. You can see there are only one data point, count is one, because few applicants use yields to apply U.S. universities, and also for GRE or GMAT. This is not a typical normal distribution, but if I exclude the outliers, it will more similar to the normal distribution. And I also use this ECDF plot to observe and discover the pattern of the numerical feature like GPA. And here you can see this ECDF or GPA is really similar to the one of normal distribution, and I can also set percentile points. By the way, my undergraduate GPA is 3.0, so which means only 5% students of applicants who has lower GPA than me and apply to Lehigh universities. And we can also draw a theoretical uh, CDF. We can see that the ECDF and the theoretical CDF fits very well, which means the Lehigh University's applicants, their GPAs follows the normal distribution. And we can also check the GMAT. It also GMAT scores. It also similar to the the similar theoretical CDF of normal distribution. And I can also do some compare the GPAs of different schools. Like here, I compare the Lehigh universities with WPI because I get admissions of these two schools last year. And this is the ECDF plot of WPI, and this is the functions in the data camp tutorial. I will draw a line. I will draw a plot. The blue one is WPI, and the red one is Lehigh University. We can say that Lehigh University's applicants' GPAs is just on the right side of WPI, which means it has an average higher GPAs. And if I do the permutation test, the p-value is zero, which means which means the difference there are statistical significant difference a mean in GPA. If we draw a plot for the uh, mean of the difference, we can say that the Lehigh University's applicants GPA minus the WPI's applicants GPA is 0.17, and in this paragraph, we can say that 0.7 will be at this place. So which indicates that there is a significant difference between the average between the mean of GPA in Lehigh University and the one in WPI. I just do some inferential statistics and descriptive statistics like this, and this is my completion so far. And after that, I will also quantify universities and majors to do more analysis, to do more data exploration. And after that, I will use linear regression, logistic regression, and other statistical model to develop algorithms and make predictions. For example, I will make a predictions based on students who has say 3.0 GPA and let's say like 95 score 95 of TOEFL and say GRE and 300 GRE. If students have a GRE of 300, GPA of 3, and TOEFL of 95, I will make a prediction about the chances he will get admission of a certain university. I will develop a model to predict that, and then I will generate some outcomes. I will uh, I will generate a match assessment to determine whether the student's background fits the school's requirement or average level. And I also provide school suggestions for students so that they will know which schools is the most appropriate choices for them. Before that, I will also take into account other factors like campus, tuition, and career development. And this is also um, important for students' choice. Okay, and this is on my project.